about the dog barking in the background. So we're going to put some negative numbers just in case we need them on this side of 0. So the first thing you do, if you remember, is we're going to look for 3, which is the number we're talking about in this inequality, and we're going to look for 3 on the number line. It's a positive 3 because I see no negative sign there. So here is the number positive 3. We're going to put a circle around that. But let me ask you, do you think we're going to color that circle in, or are we going to leave it an open circle? Well, remember, the only time we include 3 in our solution set is if this has an equal to sign under it, and it doesn't. So therefore, 3 is not part of our solution because 3 is never greater than 3. Now let's look to see which way we want to make our line go on this solution, okay? Is the number 1 greater than 3? So if I put a 1 in here, is 1 greater than 3? No. Is negative 1 greater than 3? No. So let's look on this side of 3. Is 4 greater than 3? Yes. Is 5 greater than 3? Yes. How about the number 25? Is that greater than 3? The number 100 is greater than 3. So that means our solution is going to go this way. So we're going to make a fatter line on the number line and a fatter arrow. And that is now the solution to our inequality, and it doesn't include the number 3. Let's do another one, just a little bit harder, but it's going to be easy for you since you are all such experts at solving equations. So I'm going to do this now. This says all x's plus 2, so if you add a 2 to any x or any number in the world, then it's going to be greater than or equal to 3. Well, if you can pretend for a minute that this is an equal sign, then that just looks like a simple one-step equation, which we've been doing for several weeks, and you're all experts at. So I always say to you, what is the first step for getting x by its own self? Well, who's bothering the x? The 2. And the 2 got there with what? Addition. So how do we get rid of addition in mathematics? We subtract. So we're going to subtract 2, and whatever you do to one side of an inequality, you have to do to the other, just like on an equation, or else it'll fall over. So we're going to subtract 2 from this side, and that's going to make 0, and we like 0 because x plus 0 is going to equal x. So that's what we did that for. Now we have to subtract 2 from this side because whatever you do to one side, you do to the other. So when I subtract 2 from 3, I get 1, or my solution to this inequality is x is greater than or equal to 1. Now, I'm going to erase this little number line here, or part of it, and let's use this one again to graph our new inequality. So, I'm going to put some numbers back here that'll let me write. It's a little wet. 4 and 5. Okay, so x is greater than or equal to 1. We look for 1 on this number line, and the positive number 1 is right here. And we're going to put a circle on it, if you remember. That's what we always do. My circle's not coming out. So we're going to put a circle on it. Get a different marker. Okay, so that shows up a little bit better. So we'll put a circle on the 1, and now we're looking for all numbers that are greater than or equal to 1. So is negative 1 greater than 1? No. Is 0 greater than 1? No. So it looks like we probably want to go on this side. Is 2 greater than 1? Yes. But wait a minute. We know we're going this way, right? 4 is greater than 1. But what kind of dot are we putting this time on the 1? If you can see, this says greater than or equal to. So can 1 be greater than or equal to 1? Yes. So this time, we're going to color in that dot. And I think we're going to go this way, don't you think? Because is 3 greater than or equal to 1? Is 4 greater than or equal to 1? Yes. So we're going to go this way. So that's the solution to that inequality. Some of you, I'm sure, have noticed that I did the corny joke over here on the side. And I forgot to start out with that as I usually do in class, and someone raises their hand and reminds me, and I bet you've been trying to remind me. The corny joke for today is, what kind of tree fits in your hand? I'll give you a minute to think about it, and I'm sure you're shouting your answers out now, bothering your parents and your siblings. But do you give up? What kind of tree do you hold in your hand? a palm tree, of course. Again, one of Mrs. Cole's corny jokes. Okay, so inequalities, we started some inequalities here today, and we did some of these before the break. Let's do a few more and see if you can help me solve inequalities as well as you helped me solve equations. Let's make up another inequality. We can erase this one right now. We don't need x is greater than 3 anymore. We already solved that one. That was easy, wasn't it? Okay, let's do a different one. How about if I say n, switch up my variable, minus 4 is greater than 5. Okay. So again, this one isn't quite so simple because we don't know what n is, but we know that any number, subtract 4 is going to be greater than 5, is going to be the solution to this inequality. So if we, again, try to get n by itself to make it easier, we want to get rid of this guy right here who's next to the n, just like when it was an equation. So what we're going to do is we're going to add 4 to each side because you guys know that the 4 was originally subtracted from the n, and when you owe me $4 and then you give me $4 back, now you owe me 0, and we were going for that 0. So we're going to add 4 to each side of that inequality. Then we're going to be left alone with n because that makes 0. Copy down your greater than sign, and 5 plus 4 is 9. To graph that inequality, we're going to put some numbers on the number line, and we're going to go 1, 2, 3, and if you notice our number is 9, so we really probably want to go all the way up to 9, and I'm going to run out of room, so I better make it bigger. 5, 6, 7, 8, 9, and I'm going to go to 10 and 11. All right, so I don't think we need any negative numbers, but let's put -1 there. I want all numbers n that are greater than 9. So first you look for the number 9, and you put a circle on it on the number line. Since this is all n's greater than 9, do I leave this open or do I color that circle in? Well, if you notice, there's no equal to, so that means 9 is not included in our answers for this inequality. So 9 does not count, and it can't join our party. So what we're going to do is we're going to leave the 9 empty or hollow, and then we're going to make our line go this way because we all know that 9 is not included, but 10 and 11 and 12 and 20 and 200 and 1,000 are all going to be included because all of those numbers are greater than 9. So that's my simple lesson on inequalities and solving inequalities with addition and subtraction.